A very good morning, dear children. Today we are going to see the remaining part of the chapter number 3, Current Electricity. Now let us see one activity, children. Material required for this activity: copper and aluminum wires, glass rod and rubber. So you have to make first of all connections that is shown in the figure 3.6. First, connect a copper wire between points A and B and measure the current in the circuit. Then in place of copper wire, connect this aluminum wire, glass rod and rubber. And that you have to connect one at a time. And then afterwards you have to measure the current each time for this copper wire, aluminum wire, glass rod and rubber. So when we will measure the current with the help of this ammeter, children, we will understand that from copper wire we are getting more amount of current, whereas from aluminum wire we are getting less amount of current. But when we are attaching glass rod or rubber in between point A and B, then from that there is no passing of electric current. Okay, because this glass rod and rubber, they are bad conductors of electricity. Now let us see, children, conductors and insulators. So we have learned about the resistance to an electric current. So we can divide substances into conductors as well as insulators. So conductors are good conductors, whereas insulators are bad conductors of electricity. So what is called as conductors? So the substances which have very low resistance are called as conductors. So current can flow easily through such materials. Now insulator, the substances which have extremely high resistance and through which current cannot flow, that is called as insulators. Now first question, why are some substances are conductors while others are insulators? So a substance that contains almost free charges. Normally there is a presence of electrons, that is called as conductor, while a substance which have very low electrical resistance is called as conductor. For example, copper and aluminum. A substance that do not contain any free charges, that is there is no electron, that is called as an insulator. Or a substance which has extremely high electrical resistance is called as insulator. So for example, rubber and wood, these substances have very high electrical resistance. So they are bad conductors of electricity. So it is called as insulators. Now second question is there, children. Why can our body conduct electricity? Make a list of conductors and insulators you see around you. So our body contains nearly free positive and negative charges, and hence they can conduct electricity, because in our body, children, there is a presence of positive and negative charge, and negative charge means electrons. Okay, so from these negative charges or from these electrons there is a passing of electric current, and due to that our body can conduct electricity. Now make a list of conductors and insulators you see around you. So there are some good conductors. Example, that is nail, that is made up from iron, copper wire, paper clip, that is also made up from iron, scissors, that is also made up from iron, then pencil lead, that is graphite, drinking water, lemon juice, milk, mercury. These are all the examples of good conductors. Now let us see bad conductors. Wool, wood, rubber, plastic, vinegar, honey, fuel, distilled water, glass. These are all the examples of insulators. So insulators are bad conductors of electricity. Now let us see, children, experimental proof of Ohm's law. So material required for this experiment are 4 cells of 1.5 volt each, ammeter, voltmeter, conducting wires, nichrome wire and plug key. Now procedure, set up the circuit as shown in the figure 3.7. Now use the nichrome wire XY as the resistance. Now connect one of the 4 cells as shown in figure 3.7a. Take readings of ammeter and voltmeter and enter them in the table below. Now add the rest of the cells one by one as shown in the figure 3.7, that is B, C and D. Now enter the readings in the table for each case. Determine the values of for each case and then draw a graph between current and potential difference and study it. Okay, so here you have to determine the values of this potential difference and current, that is with the help of ammeter and voltmeter. So we have to study the graph. So when we are plotting the graph potential difference versus current, children, then obviously that graph is coming straight line. Now whichever observations you will get from this Ohm's law, then that can be mentioned in this observation chart, that is number of cells used. First of all, one cell, next time two cells, then three cells and then four cells. And with the help of ammeter and voltmeter, you can measure the values of current, okay, that is in milliampere or ampere, and then potential difference in volts. And afterwards, you can take the ratio of potential difference and current. Then you will understand that, children, this potential difference and current value remains constant. Okay, means that is called as resistance, and that resistance should be in ohm. Now let us see, children, system of resistors and effective resistance. A resistor is a two-ended component having a given amount of resistance between its two ends. In several electrical devices, a number of resistors are connected together in different ways. So Ohm's law is applicable to all such connected resistors. Now let us see, children, resistance in series. So resistors are given in the figure 3.8. So you can see that the ends of the three resistors are connected so that they follow one after the other in a single line. So these resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. So the value of current is I and potential difference C and D is V. So the three resistors R1, R2 and R3, these are connected in series in the circuit. If V1, V2, V3, these are the potential differences of every resistor, that is R1, R2 and R3 respectively, then potential difference V is equal to V1 plus V2 plus V3, that is equal to equation number 1. But suppose, children, if Rs is the S for series, S is for the series, Rs is the effective resistance between C and D, that is between point C and D, then according to Ohm's law, we can write V is equal to I into Rs. So obviously for V1 we can write V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. So substituting all the values in equation 1, we get IRS is equal to IR1 plus IR2 plus IR3. So therefore RS is equal to R1 plus R2 plus R3. Because from right hand side I is common from IR1, IR2 and IR3. So obviously it will cancel with left hand side's I. So we will get Rs is equal to R1 plus R2 plus R3. But if n resistors are connected in series, then Rs is equal to R1 plus R2 plus R3 plus dash 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 plus Rn. So this is the equation for resistance in series. So if resistors are connected in series, the same current flows through each resistor. The effective resistance of the resistor is equal to the sum of their individual resistances. The potential difference between the two extremes of the arrangement is equal to the sum of the potential differences across individual resistors. So the effective resistance is larger than each of the individual resistance. And this arrangement is used to increase the resistance in the circuit. Now let us see, children, do you know? When resistors are connected in series, they are connected one after the another. If any one of them does not function, then the circuit breaks and there is no flow of electricity. If two bulbs are connected in series, they will both give less light than if they had been connected individually. So when both the bulbs are connected in series, means one after the other, then obviously there is a passing of electric current to both these bulbs. Okay, so due to that, this light will give less light from this bulb. We will get less light. Okay, if three bulbs are connected in series, their light output will decrease further. Okay, so when we are connecting three bulbs in this series, then obviously again that light output will decrease little further. Now think about it. What is the reason behind this? Means when two bulbs are connected in series, we are getting less light. But when we are connecting three bulbs in series, then we are getting less light than previous. Because when we are connecting bulbs in a series, children, that time what happens? This electric current is passing to both the lights, okay, or both the bulbs. And due to that, there is a dividation of this electric current, means this current will divide, okay, and due to that there is a less light will get from two bulbs, and obviously when we will use three bulbs, then again that current will divide more, and due to that we will get less amount of light from these three bulbs. Now, do you know the resistance of some conductors becomes nearly zero if their temperature is decreased up to a certain value close to 0 Kelvin, that is K. So, such conductors are called superconductors. Some conductors do not obey Ohm's law, so such conductors are called as non-ohmic conductors. Okay, so when resistors of some conductors is becoming zero, then obviously the temperature will decrease to a certain value that is close to the temperature, that is Kelvin, and such conductors are called as superconductors. But there are some conductors, they are not obeying Ohm's law. Such conductors are called as non-ohmic conductors. Now let us see, children, resistors in parallel. So resistors are said to be connected in parallel when their ends are connected at both the sides as shown in the figure 3.9. So the figure shows three resistors, that is R1, R2 and R3. They are connected in parallel between points C and D. So V is the potential difference between point C and D. And let I1, I2 and I3 be the currents flowing through R1, R2 and R3 respectively. Then the total current flowing through the circuit is I is equal to I1 plus I2 plus I3. That is equation number 1. Now let Rp, that is P for parallel, let Rp be the effective resistance between C and D. So therefore, according to Ohm's law, I is equal to V upon Rp. Similarly, I1 is equal to VR1, I2 is equal to VR2 and I3 is equal to VR3. So substituting these values in equation number 1. So therefore, V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Now this V will become common from right hand side. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Because here this V is cancelling from right hand side as well as from left hand side. And therefore we are getting expression 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now if n resistors are connected in parallel, so therefore 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dash 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 plus 1 upon Rn. So this is the expression for resistors in parallel. Even if any one of the several bulbs connected in parallel becomes non-functional because of some damage to its filament, so the circuit does not break as the current flows through the other path and the rest of the bulbs light up. So when several bulbs are connected in parallel, they emit the same amount of light as when they are connected individually in the circuit. While bulbs connected in series emit less light than when connected individually. Okay, so when these bulbs are connected individually in the circuit, then they will emit more amount of light. But when they are connecting in series, they will emit less amount of light. Now, if a number of resistors are connected in parallel, the inverse of the effective resistance is equal to the sum of the inverses of individual resistances. Now, the current flowing through an individual resistor is proportional to the inverse of its resistance, and the total current flowing through the circuit is the sum of the currents flowing through individual resistors. Now here the potential difference across the end of all resistor is the same. The effective resistance of resistors connected in parallel is less than the least resistance of individual resistor. Now this arrangement is used to reduce the resistance in a circuit. So such type of arrangement can be used for reducing the resistance in the circuit. And there are some potential difference across this end of all the resistance that will be same for this parallel connection. Now let us see children domestic electrical connections. The electricity in our homes is brought through the main conducting cable either from the electric pole or from underground cables. Usually there are three wires in the cable. One is called live wire which brings the current. It has a red or brown insulation. The other wire is called neutral wire through which the current returns. It is blue or black. In India, the voltage difference between live and neutral wires is about 220 volt. Both these wires are connected to the electric meter through a fuse. Through a main switch, they are connected to all the conducting wires inside the home so as to provide electricity to every room. In each separate circuit, various electrical appliances are connected between the live and neutral wires. So the different appliances are connected in parallel and the potential difference across every appliance is same. The third wire is called as earth wire and is of yellow or green color. This is connected to a metal plate buried deep underground near the house and is for safety purposes. So these are all the information about domestic electrical connections. Now let us see children fuse wire. Fuse wire is used to protect domestic appliances. It is made of a mixture of substances and has a specific melting point. It is connected in series to the electric appliances. If for some reason the current in the circuit increases excessively, the fuse wire gets heated up and melts. The circuit gets broken and the flow of current stops, thus protecting the appliance. This wire is fitted in a groove in a body of porcelain like non-conducting material. So for domestic use, fuse wires with upper limits of 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere and 10 ampere are used. Now, precautions to be taken while using electricity. Electric switches and sockets should be fitted at a height at which small children cannot reach and put pins or nails inside. Plug wire should not be pulled while removing a plug from its socket. Pull a plug. Okay. So before cleaning an electric appliance, it should be switched off and its plug removed from the socket. One's hands should be dry while handling an electrical appliance. And as far as possible, one should use footwear with rubber soles. As rubber is an insulator and due to that it prevents the current from flowing through our body, thereby protecting it. So we will not get any electric shock due to this rubber footwear. If a current gets an electric shock, you should not touch that person. You should switch off the main switch, and if the switch is too far or you do not know where it is located, then you should remove the plug from the socket if possible. If not, then you should use a wooden pole to push the person away from the electric wire. So these are the main precautions that we have to take while using electricity. Thank you children for watching the video and for your attention.